In the last course, we discussed deviation handling and root cause analysis. We learned that variances in any quality process lead to a nonconformity or a deviation. We know that any nonconformity or deviation, either from process variances or complaints, should be recorded and prompt action should be taken to control and correct it. After the investigation is completed and the root causes are known, it is time to identify and document an action plan to avoid recurrence. In this short course, we will review the importance of taking action to eliminate the cause or causes of any nonconformities or deviations. The main goal of this process is to prevent a negative event from reoccurring. This training will focus on one of the phases of deviation management flow, Phase 4, Action Plan, CAPAs. A corrective action is designed to address or eliminate the cause of an error, such as a nonconformity, that takes place in a quality process and prevent it from reoccurring. This involves understanding the root causes of the problem and eliminating them. A preventive action is designed to keep potential nonconformities from reoccurring in the future. The CAPA process is a powerful system for improving a quality management system, QMS, and avoiding future nonconformities. It is one of the main pillars of a good QMS. Managing corrective and preventive action activities is a significant focus area for life sciences manufacturers. Complaints, nonconformities, and out-of-specification results should all generate a CAPA file, but the FDA continues to find fault in the way these matters are handled. Below, you will find an excerpt from an FDA warning letter. The investigation failed to establish a root cause and your quality unit failed to ensure the implementation of adequate corrective actions to prevent future recurrence. The main purpose of a CAPA system is not only to eliminate the consequences, but also to address the causes of nonconformities or deviations and to prevent them from occurring in the future. The more robust an organization's CAPA system, the more effective its continuous improvement process will be. The CAPA process corresponds to Phase 4 of the deviation management process. It is a part of a resource-intensive activity used to achieve the organization's quality goals. Phases of deviation management flow. Phase 1, deviation and nonconformity identification and reporting. Phase 2, investigation and root cause analysis. Phase 3, risk assessment. Phase 4, action plan, CAPAs. Phase 5, CAPA effectiveness check. Phase 6, periodic review. With a robust QMS in place, you can collect and analyze information about product and quality failures based on statistical methodology to detect recurring quality problems as needed. Remember to use information from different sources to identify and investigate the causes, phases 1 to 3. Some of the events that may need a CAPA include change controls, nonconformities, deviations, complaints, product rejections, recalls, internal and/or external audit observations, regulatory inspections, staff observations, trending data, continuous improvement initiatives, out-of-specification results, out-of-trend results, and product quality reviews. Let's begin by exploring the reason a CAPA system may be ineffective. Later, we will discuss how to establish an effective CAPA system. One of the reasons you may have an ineffective CAPA system is the inefficient tracking of information in your QMS. You already know that data can be managed by way of a manual, electronic, or hybrid system. A reminder that manual systems can be challenging as they are usually unconnected and managed by different people. Manufacturing, quality control, auditing, complaints, and R&D are some of the processes that depend on different managers. These processes are usually placed in different systems and regions. The way they are managed may differ depending on the process. This misalignment may happen because there is no systematic way to collect data. Reporting failures and investigating data are crucial in this process. When manual trending is used, it may be not efficient enough because manual systems are generally not connected, and it is difficult to provide accurate data at the time it is needed. Current technology, however, can offer digital tools within a single centralized platform. While this is a topic for another course, it's important to know that this integration promotes a global visibility of potential problems and facilitates management oversight of the data by way of a standardized process. That said, the ineffectiveness of certain CAPA systems is not only due to the use of manual processes. Here are some of the other reasons you may have a weak CAPA system. Superficial investigations happen when you focus on symptoms rather than applying a systematic approach to solve the root cause of the problem. For example, a superficial investigation may take place when a pH result, 5.5, is at the limits of the specification, 5.5 to 7, and you focus investigation on the robustness of the pH meter instead of the robustness of the manufacturing process. Another tip for performing a good root cause analysis is to go and see for yourself where the event occurred. This is called Genchi Genbutsu, one of the key principles of the Toyota manufacturing system. It indicates that problems are not solved from the desk. Instead, they are solved by visiting the production floor, the quality control premises, the warehouse, or wherever the event happened to assess the process. A final tip is to focus on the process rather than the people. People are not always the source of the problems you encounter. Map out the process with a personal expert where the nonconformity occurred. Draw a flow diagram and aim to understand it. Lack of knowledge and expertise is another reason you may have a weak CAPA system. It is common knowledge that the purpose of a single CAPA is not only to solve a problem, but to extend the action to other similar problems. It is better to make a decision within a cross-functional group to ensure your organization considers everyone's perspective and past experiences. The absence of robust effectiveness checks is yet another potential weakness. Not all CAPAs result in process improvement. If you do not perform effectiveness checks after implementing a CAPA, you will not know whether the CAPA is negatively affecting the system. For example, imagine you get an out-of-specification result in a batch of medicinal products due to a new unknown impurity. All you have at this time is a hypothesis based on one question. Why does the product fail specifications? The response: because a previous intermediate was not tested. Imagine you do not perform root cause analysis using the 5 whys and you decide to implement a CAPA by only testing the intermediate product. Do you think this action will solve the nonconformity in the future if the problem is not the intermediate testing, but the poor quality of the starting material? Take a moment to consider this. Then, let's move on and focus our attention on some best practices for implementing an effective CAPA system. The goal is to take appropriate, effective, and comprehensive corrective and/or preventive actions to ensure problems are detected and solved. In general, an effective CAPA system must be systematic. There must be a logical and structured approach to identifying and resolving issues. The level of effort of the investigation should be proportional to the level of risk. This process should be well defined in an SOP. For instance, using root cause analysis tools during the investigation phase. Proactive. CAPAs should be proactive to prevent problems rather than only addressing them after they have occurred. Continuous. CAPAs should be an ongoing process to improve quality rather than a one-time fix. Keep in mind that if we do not capture the key details of a nonconformity in real time, then we will forget the details of the occurrence very quickly. Accordingly, it's important to only accept these non-conformance procedures that allow same-day reporting or reporting exclusively by those who witnessed the non-conformity when it happened. Various potential root causes may appear after an investigation using root cause analysis tools: documentation, training, manufacturing, management, change control, purchasing or supplier quality control, testing, design, maintenance. Many organizations tend to overuse training as a corrective action and do not adequately address the systemic corrective action. Keep this in mind to make certain you find the real cause of the nonconformity. Human errors are not always the reason for the deviation and nonconformity. The degree of CAPAs taken to eliminate or minimize actual or potential nonconformities must reflect the magnitude of the problem and the risks encountered along the way. Regulatory bodies expect the manufacturer to develop procedures for assessing the risk, identifying the actions that need to be taken for different levels of risk, and determining how to correct or prevent the problem from recurring depending on the risk assessment. The main issue before applying a CAPA plan is to determine when it is appropriate. The decision should be balanced. This means you will want to make sure you neither overuse nor underuse your CAPA system. If you overuse CAPA, your organization will experience a never-ending process with a huge backlog of open actions. This prevents issues from being solved quickly. Conversely, if you underuse CAPA, you will not be able to improve quality to the appropriate extent and prevent the recurrence of nonconformities. Now let's review some general steps for creating a robust CAPA process. First, focus on systemic critical nonconformities with higher levels of risk. Nonconformities that may result in health risks are the first ones to address. Prioritize CAPAs based on trending. Determine whether there are similarities with other nonconformities. Sometimes different nonconformities originate from the same root cause, and a global CAPA system can resolve several nonconformities at the same time. Focus on customer complaints. These are critical from a regulatory perspective. Continue with nonconformities from products, process deviations, and audits. Update the procedure and redesign the process. Assign a responsible person and a target date for performing each action. Assign a QA person to follow up and verify the action has been implemented. Schedule and implement additional staff training related to the change. Apply the change. Have the above-mentioned QA person review the CAPA register on a monthly basis to verify the target closure date of each CAPA and communicate with the CAPA owner. For delayed CAPAs, the owner should request an extension for closure. They must provide proper justification and an impact assessment. Effectiveness checks consist of verifying the CAPA is effective and has not adversely affected the product or service. This can be accomplished by reviewing product and quality problem trend results and checking whether similar or additional quality problems exist after the CAPA implementation. You should ask the following questions. Did my CAPA work? Did my CAPA create other potential nonconformities? We will review 2 case studies. Let's start with the first case. A pharmaceutical manufacturer was manufacturing a batch of tablets for a medicinal product, and initial tests during scale-up showed that some of the tablets had separated into layers. This nonconformity resulted in QC or QA rejecting the batch. The investigation that followed revealed a lamination problem. This caused the tablets to separate into 2 or more layers. Root cause analysis identified an excessive quantity of dry granules of the bulk product due to poor drying conditions. In other words, the granules were overly dry. There are two CAPAs that can be applied. Which one is preferable? The best CAPA is CAPA 2, because the real root cause is the poor drying process. If we solve this process, then the bulk product will be consistently okay, and there won't be any need to add hygroscopic materials to the tablet. Case 2. A weighing balance is used during the manufacturing process. After several batches were produced, the manufacturing department verified the instrument and identified it was out of calibration. The 10 lots that have already been tested and released. 1 lot has been delivered to a customer and 9 lots are in release status in the warehouse. During the investigation, root cause analysis was performed. It became clear the last calibration report of the weighing balance was correct. The reason for the deviation was the minimum weight. The rest of the parameters were okay. Consequently, a new calibration was performed to verify the parameters were okay and determine a higher minimum weight. After the risk assessment, all weights below the new minimum weight were deemed at risk of deviation. The investigation identified that the tolerance issue had affected the weight of one of the components in all the manufactured lots. This component was weighted below the minimum weight. Which CAPAs would you apply? Corrective action. First, for the lot that was delivered, the customer should be informed and the lot should be recalled. The other 9 lots in the warehouse should be separated from the approved area and moved to quarantine until they are retested. Preventive action. Reduce the calibration period or the weighing balance to 1 month. Apply sensitivity testing before use according to the current USP. That's all. Thank you for attending this course. I hope you found it useful and that you have learned what you expected. See you in other courses at Scilife Academy to continue your learning journey.